Welcome to the Duke's Chemical Root Control for Engineers webinar. We certainly appreciate everybody taking time out of your busy schedule to join us here today. My name is Mike Bean. I'm the National Technical Manager at Duke's and have going on about 24, 25 years of experience in the wastewater industry. Just a quick bio. I'm a licensed professional engineer in North and South Carolina and graduated from Clemson University with a degree in electrical engineering. And I am married with 5 kids, happily married. And my oldest kid is 16, and therefore I'm a busy man. So on the webinar here, you should see at the bottom, there's a Q&A button that's designed to, if you want to submit a question, what we're trying to encourage is to utilize that to post a question. And then at the very end of it, Caitlin, our marketing director, will reel through the questions, and we'll also have an opportunity for people to unmute if you want to just ask a question or kind of discuss. So thank you again for joining us. And I think this ought to last maybe, I'm going to say 25 minutes or so, something like that. So with that being said, we'll jump right into it. So hopefully everybody can see my screen here. This is the chemical root control, and for engineers, it's set up to be, for consulting engineering companies, or maybe an in-house engineer, but that's just kind of the way that we've formatted this one. So the objective here is for all the participants to gain enough knowledge to be comfortable speaking with utilities, or if you're external or internal colleagues, about chemical root control, pertaining to the wastewater collection system, and understand its potential role in operating and maintaining a wastewater collection system. So the topics will include roots and sewers, kind of the how, what, when, where, why. And then number 2, as we'll soon see, roots exist for sure. What are the options? So we'll run through that. Number 3, making the case for chemical root control and just understanding what it is, how it works. And then number 4, just a quick touch on roles of engineers, collection system, and then provide a couple of examples. So diving right in, the EPA states the intrusion of roots into sewers is probably the most destructive single element that faces those maintaining wastewater collection systems. That's a pretty bold, strong statement there. And then, if you just poke around Google and look around on the internet, you'll see this is a screenshot from just that. All sorts of articles and information popping up, but studies show that tree roots are a significant problem in sewer systems, contributing to blockages, damage, pipe damage, and so forth. Roots can enter sewer pipes through cracks, leaks, deteriorated joints, and their growth can clog pipes, reduce flow, and even, hang on one second here, sorry about that, and cause pipe damage. So just kind of establishing that roots are, they're part of the sewer system here, and it's a problem. So what's going on with roots and sewers? So, trees and plants are growing all over the place, right? And down below, where the wastewater collection system pipes are, there's an unlimited supply of water and fertilizer, air, and generally perfect conditions for plants' roots. And then the third point here, if you've been in the wastewater collection system for any time at all, you would know that the pipes are not perfectly tight. We see a lot of I&I. We do a lot of I&I detection and so forth. That's a big part of our business. But, we all know that the pipes are not perfectly airtight, preventing roots from getting in. So looking at characteristics of root systems. So, just an example on the left at how robust and strong a tree's root system can be, just a quick visual. And then this topic of drip lines and how far roots can grow, this little diagram on the right. Root structures can be 4 to 7 times the size of the drip line area. So, you start calculating, area versus this outside circumference, that area can be much larger than the tree. And in doing some homework here, preparing for this, I ran across cases where roots have been discovered miles, plural, far in distance from the original tree. So, you know, just trying to show that roots can be, grow long distances. And then some other characteristics of roots, we've all been walking along and tripped at some point. And, just some examples here of the strength and the destructive nature that can exist with roots. In particular, this bottom one, kind of in the middle there. I mean, look, that root's just mayhem on the sidewalk there. I'd hate to be walking through there, but we've all seen it plenty of times. Roots can, growing next to a building can, damage a reinforced concrete foundation. So, that being said, certainly, roots have a destructive power. And when you start talking about, well, a sewer system has pipes that are 50 and 60 years old, it's not a stretch to think that roots can cause physical damage. So in these examples, roots are breaking concrete, and these are important to note here. These are without unlimited water and nutrients. So these are topside, and not getting the turbo fuel that's down below. So with all that being said, typical outfall here, this is East Coast, a lot of vegetation. You can see a manhole there in the forefront, and the lady walking on the trail, and another manhole back, behind her, the pipe segment down below this. But, not a stretch to think that these roots from the vegetation on the sides, even though this is a really, really well maintained right of way, those roots can make that distance. And just making a point here, just because you don't see, it's not obvious. There's not an oak tree growing right on top of the manhole, right? There can be problems. And some examples of that here. So, on the left here, you see this field tech holding this big massive roots that have been mechanically pulled out of a sewer. If you notice in the top right of the picture, there's a boom. So there's some sort of crane mechanism. And look, they got a root out. They got one root out in one pipe segment, and there are three field guys there. There's one taking the picture, probably, right? So expensive consequences, right? Like there are multiple trucks, there's equipment laying around. They didn't just show up and pull that out in 5 minutes, right? And then this photo on the right, just another example of, I mean, obviously the flow of water in that tangled up mess, it's not it's not ideal for sure. So some other consequences, the EPA estimates that there are at least 23,000 to 75,000 SSOs per year, and SSO meaning sanitary sewer overflow, sewer on the ground. And that's not including sewage backups into buildings and homes and so forth, right? And we probably all know that, it's not a stretch to say that not every single SSO gets reported. We all know that, right? I mean, sometimes they maybe aren't seen, but those numbers are probably larger, but nevertheless, those are large numbers. So some consequences further here going, root associated issues. You see the photos there. Roots, once they enter the pipe, can fracture the pipe, separate the joints, and cause literal physical destruction of a pipe segment. That in turn can cause increased customer emergency calls with backups and so forth. And, which utility has extra time these days? Nobody has any extra time, right? So most utilities are wearing multiple hats, and the thought of four people going out and with a crane and pulling sewer out, that's not a very systematic and methodical way to deal with a problem that, likely is there's more than just that one, right? So, and then the increased grease and debris buildup. These photos on the bottom, obviously any grease, debris, would just get filtered and build up even more. And it certainly can cause a reduction and stoppage of flow. just to look at some pictures at, the speed and pace of root growth. I mean, on the left there, you see a little bit of, kind of hair root, fine roots getting in. And just after 10 months, the pipe is essentially full. So very, very fast root growth in the sewer system. So now that we're kind of beating the dead horse here, and we've established that roots growing on inside of the wastewater collection system is a problem, let's look at like what the choices are dealing with this problem. And probably many people here have experience with mechanical methods, those being rotting machines, bucket machines, and then hydraulic cleaners, probably the most prevalent. That being I've listed here jet truck, but it could be a combo truck, or commonly, people use the term vac truck that also has a jetter system on it, so a combination vehicle of some sort. And then the cutting tools that attach to the jetter system, whatever it is, it could be a trailer type setup. So, rotting machines not used very, yeah, personally, I don't see people using rotting machines anymore. That's just where, mechanical rods are connected, inserted into the sewer, rotated, just to kind of, it's kind of like the sewer snake, the industrial version of the residential version that people have seen. Bucket machines, I hear of them being around somewhat, but that's a physical bucket that's installed in one manhole and mechanically pulled through, just ripping away whatever it is. The jetter trucks that jet at 80 gallons per minute on as most common value, that's probably the most common. And then we'll kind of take a look at some cutting tools here. But you know, these methods are very expensive. They can damage sewer pipe, and at the end of the day, they don't fix the issue. Uh, I'll say this. I'll add this in. The use of these cutting tools, like in this bottom left photo, look, that's for a very experienced field person that's run a combination truck most of the time, right? That's used that for many years. That's not a tool that you just kind of put in the sewer and hit the go button and take off. There's lots of problems. This thing can get hung up, cause dig ups, etc. And I've been around that sort of thing. So looking at the cost here in particular, you know, just kind of as a rough cross comparison, a good day for TV cleaning crew could be 8 segments per day, and that number obviously could go down and it could go up some, right, if it were easy to access and so forth. But that's a good kind of rough average for a productive day. When you introduce cutting roots mechanically like this, I mean, you're talking about a rate of production that's less than 1 segment per day. I mean, I've been around one that was several days just for 1 segment because all sorts of issues were popping up. Maybe 2 segments per day, but the point being, the time involved in this mechanical cutting is much longer, and that's reflected in the cost. So just kind of doing the basic math here with this particular example, you're talking about a cost that's 4x, what TV cleaning would be, to 8x, right? So just pointing out my or the part of it, that part of it. So yeah, looking at some pictures here, and I see I failed to insert one picture I meant to put in, but yeah, you can see some challenges here with a cutting tool that's commonly used. A protruding tap, this is a service lateral that's clay. It's a hammer tap. Any kind of, these tools need a rifle barrel to get down through. So offset joints, protruding taps, any kind of broken items that are existing in the sewer, are problematic. And then you could see the red arrow here with, there's literally a piece of the pipe that this gentleman brought back, and his blades torn up. And you can, they were probably lucky to get the jetter hose back without digging, and maybe they did dig in that case. Okay, so kind of getting back to the plants and the roots part of this, if someone wants to have the highest level of health in a plant or tree, what is one of the most common techniques to foster growth and good health? And, we all do it around the house, or probably a lot of us, but, I'll pull up an example of a, grape or muscadine vine here, but it's pruning, right? So there's a lot of, you talk about farming and growing trees and all that, there's a lot of pruning going on. It's one of the most basic techniques to foster good, robust growth, right? So when you start talking about roots, cutting the roots mechanically is no different than pruning a tree. It's helping the growth, right? So not only are we not fixing it, we're helping the growth, right? So you turn the tree upside down, and that's what's going on here. So now that we know mechanical root cutting is difficult and expensive, and adding to that, it's a reactive, right? It's waiting until, right? Is there another method, preferably one that is established, tried, true, with lots of supportive data demonstrating its effectiveness? Not to mention being proactive, of course. That's the topic here, what we're getting into. So just to introduce Duke's chemical root control, a very long history. It's more than 40 years. You can see this. This is one of the oldest photos that we circulate kind of internally here. That truck is older than 40 years, and that's one of the original Duke's family members. But the company started a long time ago, and there's been a lot of development and refinement of the process naturally over 40, 50 years. At this point, we're talking thousands of clients doing this. And an interesting data point here, enough treatment and supportive data to circle the earth 3 times. So just kind of taking the basic look of like kind of how it's deployed in the field and some key characteristics. Key characteristics, number one is it needs to be effective, right? It needs to work. And when you get out the 40, 50 years, we're going to take it for granted that it works here. The second bullet point, very important here, safe for the downstream wastewater treatment plant. Look, if you don't already know, wastewater treatment plants are a biological running treatment facility. Any upset of the biological process, would completely disrupt the treatment process. So, all of that has been, tested. Again, when you get out 30, 40, 50 years, and you're on many iterations, this is just not something that's talked about within Dukes. Like it's just, there's been too many case studies and examples where it's just not a big concern. We can provide lots of information on how that, and the examples on how that's not a problem. And then the third bullet point, just the cost effective nature. We looked at the one example of the big root, but even small roots, very expensive. So yeah, so the first step here is the vehicle. You can see the specialty vehicle that's set up to apply the product. It pulls up to the manhole and does all the safety procedures. And the second step is the operator opens the manhole cover, deploys the I keep wanting to call it the jetter system, but the applicator hose, and it gets pushed from one manhole all the way to the next manhole. The pumping system is turned on, applies the product, and it pulls back, at a rate of 1 to 2 feet per second. The consistency of the product is very much like a shaving cream type consistency, and it fills up as it comes back. If there are any laterals, it may go up the lateral 4 or 6 feet or something on that order, and that's how it's applied. So it's pretty quick and easy. But again, some key bullet points here. These techniques are a product of 40 plus years of refinement. The foaming action brings the herbicide that's doing the killing of the roots. It allows the product to stick to the roots and it be as effective as possible. There's a degreaser component in the foaming, and it helps expose the roots, get rid of the grease, and get the product to the root. And in the case of Dukes, there's a 3-year warranty offered. So a lot of confidence here in, how it's applied, the chemicals that are used, and so forth. So uh, we've got the data here to show the reduction in sewer stoppages on the order of like 80 to 95%. So with that, lots of benefits, including, a reduction in related off-hour sewer calls, less headaches, a reduction in overtime related costs, and, think the simple things like decreased SSOs. I mean, that's key here. And, can be, this is information coming from utilities that we've worked with, a boost in utility morale. SSOs are problematic. So, and then there's the sustainability. There's less SSOs, and the pipe isn't subject to, the fracturing that roots can foster. So what's the purpose of a wastewater collection system? Of course, number one, get the sewage to the wastewater treatment plant, all of it, and nothing more, no I preferably, a subject for a different day. But so the engineer, typically when we're this is for engineers, when you get an engineering company or an engineer involved with, trying to systematically plan, projects and evaluate a collection system, there's something along these orders of something like these 4 steps here. So, this isn't exactly perfect for everybody, but hopefully it's just to provide kind of a rough sketch of how it would be on average. But, systematically evaluate the collection system. So there's the evaluation step. Number 2, try to determine which areas get the limited dollars. Like, nobody has unlimited dollars. Fix the problem areas, whatever those may be: broken pipes, point repairs, design build, find, fix, etc. And then number 4, an effort to set up a long-term plan with proactive and a sustainable workflow, some sort of like proactive operation and maintenance plan. So as we all know, engineering at its core is using scientific knowledge and data to design and improve system and processes, to solve real world problems, this being a good example of one. So now that we know that roots are arguably, some say it's the worst problem, some say it's a significant, arguably one of the largest issues in wastewater collection system maintenance. Here, a key question is this: does it make sense to systematically ignore this concern and apply expensive and damaging principles to fix the problem? Of course not, right? So enter the EPA CBOM program, which every collection system should have have a version of this that's fixed up for themselves there. CMOM stands for Capacity Management, Operation, and Maintenance, and it's a utilities plan to manage and operate their sewer collection system. There's hundreds of billions of dollars get spun out of this in rehabilitation needs, and we touched on large number of overflows. And SSOs at the end of the day are not desirable and a threat to water quality. So here's my intent to be a comedian, the devil's advocate here is like, let's do nothing and just wait for there to be a problem in the CMOM planning meeting, right? Not ideal. But, should a known systematic problem have a systematic solution, or a solution that includes run to fail? And I think we all know the answer. That would be some sort of systematic solution that's, things like proactive and preventative are key pieces to that. So an effective program should be designed around this proactive preventative schedule to prevent stoppages in sewer pipes, as well as to increase capacity in the collection system and prevent future expensive maintenance and repairs. So one of the last items here I'd like to touch on is Dukes. At Dukes, in the chemical root control program, we offer a customized report. It's called Blackberry. One of the long-term Dukes guys came up with this name. He grows blackberries, but this is a report that offers an aspect of program management. It aggregates all the data, summarizes it, and look, when you have a collection system and you're doing, doing any kind of work on certain segments and not others, it can be a real challenge to keep up with, in this case, what's been treated and what has not been treated. So we've got this customized report to help with that. You can just kind of see some examples. Excuse me. This is obviously for a larger client with bigger pipe. You can see it goes up to 24-inch, and I think even higher than that. But anyways, you can see kind of how the data is aggregated per year, which pipes have an expiring warranty. And another piece to this that we're not showing is there are corresponding maps to this that we produce and provide. So it's a really great way to kind of sum things up. So some examples that we'll get into, or that I'll kind of leave off with here. Sorry, I keep getting a bunch of messages here, but a major city in the Midwest, and if anybody wants any particular examples, you probably know a Dukes person, and we're happy to provide it. I just didn't want to broadcast it, but one, since the early 2000s, this is a key piece of their maintenance and CMOM program. Things like huge reduction of SSOs, 99% success rate, systematic planning to get around the system, right? This city with the big university, another, root control, chemical root control is a key part of their maintenance plan. SSOs are reduced to the point that they just don't talk about it anymore. It used to be kind of the main discussion years ago, and it no longer is. This third one here, OMAG. So OMAG is is part of the Oklahoma municipal, and I'm gonna not remember what the rest of that is, but it's the insurance arm in Oklahoma for municipalities. They literally have a grant program that pay utilities to do root control dollar for dollar. There's some other terms and all that, but that's how strong of results that have been achieved in that area. Just a couple more here. Mid-sized town in the Carolinas. I'm in South Carolina. 35 years ago, root control was implemented. Lines were scheduled for replacement that are still in service even now, right? So, and then another comment was homeowner calls are significantly reduced. And last one here, mid-sized town in Georgia, SSOs decreased by over 90%. And this particular utility has quit cutting roots altogether as a maintenance years ago. And last bullet point, over 95% at Dukes remain clients year over year. What does that mean? That obviously translates into it works, and it's in one way or the other making the utility's life better. And we all go to conferences and that sort of thing and work with utilities. Feel free to ask around, and I think you'll hear some positive things. So with that being said, we can, Caitlin, if you have any questions, you can jump on those now. And I've got I think the audio is, you good? I've got the contacts here of the coverage throughout the country. If you know one or need an email address, I think it hopefully is mostly right. So let me just quickly, everybody, thank you for attending, and appreciate the time. And if you're out of time, you feel free to jump off, and we'll jump into questions that if anybody has submitted them via the Q&A. And then if anybody wants to, you can, if you want to ask a question and just open up the audio, you need to hit that raise hand button, and we can get to that too. So Caitlin?
We did have a question during the webinar. Someone asked, is it typical to perform CCTV after root control is applied in order to verify that roots are gone?
Yeah, so that's a pretty common practice. I spoke with one of our main guys earlier on this, and the number that he threw out is probably something like 20% of the clients have some sort of mechanism to go back. They may do it themselves. I know of cases where we include that even, but I think the broad answer is yes, that sometimes is. And I think like as more confidence is gained as time goes on, then that probably decreases.
All right. Someone else asked, when applying chemical root control, should you cut the roots mechanically first, or does it matter if you cut first?
Yeah, so you need to not cut the root first for sure. So there's more surface area. The product needs to be on the root to be able to take care of it. So most definitely it's better to not cut it.
And the
And then
last,
I'll add quickly while you're drumming up. I mean, typically it takes like, the root will be killed within 24, 48 hours. And then the root typically is gone in the 60 to 120-day range. And then it dies, decays, and just sloughs off and goes away in that time frame.
okay. And the last question that we have so far is, how long does it take for roots to be gone?
Yeah. So that's what I was just, you were probably reading and looking at questions. The root is killed 24, 48 hours, and the root is gone like 60 to 120 days is kind of what we say. So
Sorry,
I
yes.
see, I see one more here. I don't know if it's popped up on yours or I got it here. We took care of it. Okay. Any last ones, Caitlin?
That is it so far, unless anyone wants to ask one.
Well, if anybody is still on, thank you for participating, and hopefully you got something out of it. And if you have any questions, you can reach out to probably anybody on the list here, and be happy to take care of you. All right, appreciate it. Thanks, everybody.
Bye-bye.